Hey guys, so it looks like we're still struggling a little bit with single replacement reactions. So I'm going to do a few more examples and probably just add this link to your feedback on your assignment here. So I did one for you guys. 2 and 3 were very similar to number 1 in that they were both balanced. The only thing that I could see maybe making a mistake with number 3 would be the charge here. Remember, iron 2 is 2, and then sulfur is a 2 minus, so it would be FeS plus K, and then you would have potassium sulfide, which is Ks plus Fe. So just make sure when you're doing number 3, you have FeS as your iron 2 sulfide. So just make sure that's correct. So again, 2 and 3 are very similar to number 1. They're already balanced. So if you get to the end and they're not balanced, that means that your products are not correct. But I'm seeing a lot of mistakes with 4 and 5, so I'm going to do that here as well. So the biggest thing I'm seeing with number 4 is that we still are just not paying attention to where it says nitrate here. A lot of you guys are putting N instead of NO3. Remember, if it ends in ATE, it's polyatomic. Again, everything in this class comes back. It builds on itself. So if you're not remembering the ionic bonding, covalent bonding, like you need to go back and refresh yourself, because the minute you see ATE, that should tell you, oh, I need to look up my polyatomics, okay? So this is a single replacement. Let's look at our activity series. So we've got barium and aluminum. So aluminum is right here, barium's right here, so this reaction will go forward, and then nitrate is NO3 minus 1, okay? So this is very similar to your warm-up you did in Unit 3, Lesson 9, and I was noticing us struggling with that too, so let's go ahead and put this in here. So Ba, barium, plus AlNO3, 3. Okay, this has to be a 3 here because the charge on aluminum is 3 plus, NO3 is minus 1. When you swap, drop, and chop, you get NO3, 3. Okay, so, and I'm just going to copy this so I can paste it in. Now remember, like will replace like, so barium and aluminum are going to switch places. So now we're going to have aluminum by itself plus barium nitrate. Okay, so NO3. Now barium is a 2 plus, so this will be NO3, 2. Okay, that's where a lot of us were just getting thrown off. We didn't have our formulas correct. Okay, so now let's balance. We have Ba, we have aluminum, we have nitrogen, we have oxygen. And then, of course, same thing. Whoops. We've got Ba, aluminum, nitrogen, and oxygen. Okay, so we've got 1 barium, 1 aluminum, 3 nitrogen, and 3 times 3 is 9 oxygen. Okay, so 1, 1, 3, and 9. Here we have 1 barium, 1 aluminum, 2 nitrogen, and 6 oxygen. So right off the bat, I can tell this is not balanced. Again, I can tell with a 3 and a 2 for my nitrogen that we're going to have a common factor. So I'm going to go ahead and try to get that common factor, which between 3 and 2 is going to be 6. So I will put a 2 here in front of the aluminum, because 2 times 3 will give me 6. And I'm going to put a 3 here in front of this barium nitrate, because 3 times 2 will give me 6 on this side for my nitrogen. Okay, so now that I've put those coefficients there, let's rework, because we want to work as we go. So now we have 2 aluminum, 3 times 1 is 3, times 2 is 6 nitrogen, and then 3 times 3 is 9, times 2 is 18 oxygen. Now let's look at our barium. We've got now 3 barium. We have 2 times 1 is 2, times 3 is 6 nitrogen. And then 2 times 3 is 6, times 3 is 18 oxygen. Okay, so now our oxygens, our nitrogens are balanced, but our bariums and aluminums are still out of whack. That is okay because it's easy to balance those because they're by themselves. So we need 3 barium on the left, so we're just going to give that barium a 3 coefficient, and he is now 3. And then aluminum on the right needs to be 2, so we'll give him a 2 coefficient. So this should be your balanced equation. 3 barium plus 2 aluminum nitrate will yield 2 aluminum plus 3 barium nitrate. You're not going to be able to do these if you don't remember your formula names, if you don't remember your swap, drop, and chop, and if you don't know how to count atoms and you don't know how to balance. Like that's it. There's a lot. Like almost everything we've learned so far in this course is compounding here on these. So you need to make sure you're paying attention every step of the way, and that you're really applying all the knowledge that we have from this course. Okay, so now let's do number 5. I've noticed a lot of issues with number 5 as well. So here we have potassium iodide. So potassium is a metal, which is K. It's got a charge of +1. Iodine is it's in group 17. It's a halogen, so it has a charge of -1, so it's Ki plus Cl. Here is where a lot of mistakes were coming in as well. Chlorine is one of the 7 diatomic molecules, so chlorine is always Cl2. Chlorine never exists by itself on its own. It's always at least bound to another element or bound to at least one of itself. So let me go ahead and put this here. So now let's take a look. Here's another mistake we were making. Potassium is a metal. Iodine is a nonmetal. Chlorine is a nonmetal. Like replaces like. Here, the iodine and the chlorine are switching places. Okay, so iodine and chlorine are going to be switching places. So now we're going to have the chlorine bound to the potassium and the iodine on its own. So we'll have potassium chloride, which is KCl, because chlorine is also a halogen. So it's a -1. Potassium is still a +1, so it's KCl plus iodine, which is also one of those diatomic molecules. So it is also I2. So we need to make sure we do that. Now let's balance. So we have a K, an I, and a Cl. A K, an I, and a Cl. Okay, so we've got 1 potassium, 1 iodine, 2 chlorine, 1 potassium, 2 iodine, 1 chlorine. So we're going to have to balance. So I'm going to go ahead and try to get my chlorine up first. So I have 2 on the left, so I know I'm going to have to put a 2 here so I can get to 2 for my chlorine. So now I've got 2 chlorine and 2 potassium. And that means I'm going to have to balance, come back to the left and balance as well. So I'm going to put a 2 right here in front of my potassium iodide. And that will give me a 2 for my potassium and a 2 for my iodine, and that is balanced. So that is your balanced equation for number 5. So 2 potassium iodide plus chlorine will yield 2 potassium chloride plus iodine. Okay, so when you're doing these, first thing you need to notice, number 1, is this going to be, what kind of reaction is happening, right? These are all single replacement. Number 2, what's replacing what? So go ahead and identify your metals and your nonmetals. So like in number 4, we had a metal replacing a metal. In number 5, we had a nonmetal replacing a nonmetal. Okay, remember like replaces like. Number 3, you need to pay attention to, do I have any polyatomics? So like in number 4, we had that nitrate, which was ATE. So you need to make sure your polyatomic equation is correct. And then you need to look for any of those diatomic molecules. So like oxygen, chlorine, iodine, nitrogen. Those are in your notes. You need to have those with you every time you're doing these. And then, of course, once you get your formulas correct, you can make sure it's balanced. So I hope this helps with 4 and 5. again, guys, there's not much you can do for these other than practice. Practice, practice, practice. Make a list of everything you need to watch out for. And as you're doing these equations, just go through and make sure you are checking off your list and that you have crossed your T's and dotted all of your I's. Okay, let me know if you have any questions, and I hope this helps.